So in this chapter, what we're learning about is the main configurations that we need to understand to fill out orbital diagrams, as well as trends on the periodic table. So let's start off with the periodic table. So this is a crude drawing of the periodic table, and the two things you need to be able to identify are the trends in ionization energy and atomic volume. And so those are very simple. So atomic volume has that trend. The smaller the atomic volume, the lower and the further to the left it's going to be on the periodic table. And so atomic volume, you can guess what that means. It's just the volume of an atom. The other one is ionization energy, which has the exact opposite trend. The higher up and the further to the right you go, the higher the ionization energy. So I'll just label that IE and AV. And so that's what you need to know about that. Now, ionization energy is very important. Ionization energy is the energy required to strip an atom of its valence electrons. So just remember that. It's the energy required to strip an atom of its valence electrons. Now, this right here, this column right here on the periodic table is what's called the noble gases. Noble gases the reason why they're called noble is because, for many reasons, but it will not give up its valence electrons. So it takes a lot of energy to get rid of them. And so it has a high ionization energy. Now there's a few other trends. Number one is when you go down the columns in the periodic table, those are called families. The rows in the periodic table are called groups. So moving onward, you need to learn how to set up an an electron diagram like this. Now, just very generally speaking, I'm going to talk to you about what valence electrons are. A valence electron, all that is it's the electrons that are in the outermost shell. So, you know, if you've got shell 1, shell 2, shell 3, if these two shells are full and we've got one electron in here, that means it has one valence electron. And that makes this the valence shell. If there's no electrons in this one, that means this is the valence shell, and it's going to be full of valence electrons. Now, the reason why noble gases have such high energy ratio, such high ionization energy is atoms want to have either full valence shells or empty valence shells. And so, because noble gases have full valence shells, they don't want to give it up. And so it takes a lot of energy to force them to give it up. And that's why they have such high ionization energy, the noble gases, right here. Okay, now let's go on to this part right here, is how do we fill this out? It's very simple. So what we're going to do is carbon 12, because it's a neutral atom that we're going to be working with, if it has 12 protons, that means it has 12 electrons. We're going to fill it out as such. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's how you fill it out. Now you need to pay attention to the way I filled it out too. So so this right here is what's called the s orbital. And all three of these have one s orbital. The maximum number of electrons that can be in an s orbital is 2. And so we've got S1, and that'll be spin up, spin down, spin up, spin down. And so it's very important. So that means every one of these, that means an electron can exist in the same place, and it has spin up or spin down. So you can get 2 electrons there. And so S1 right here has 2 electrons. S2, it's the same orbital, just in a different place, has 2 electrons. Spin up, spin down. Now, the important thing to realize is electrons, they kind of like their space. So if you paid attention to the way I filled this out, you need to fill in so let's just say instead we've got 7 electrons that we're dealing with. So we go up here, we fill out these 4, then we have to fill out another 3. Before I put a second electron in this one right here, I have to put electrons in these 2. Only after there's one electron in all the others do I double up the electrons. So you fill up, so you put 1 in the empty before you double up on 1. And so that's the rule. And so if you ever get the question, if you get the question, how many electrons can an s orbital fit? It's always going to be 2, because these right here represent orbitals. Now, if you get a p orbital, that's different. The p orbital can fit 6 electrons. But if they ask the question, how many can the shell fit? The shell itself can fit 8. So pay very close attention to the way I did this. You've got this bottommost shell. These ones right here, they're called shells. The line that it's on, doesn't matter how many platforms it are, that is the orbital. So if you get the question, how many electrons can the p orbital fit? The p orbital can fit. So you've got 3, it can fit 6. And so just the way to go about this is just to remember you've got 1, 1, 2, 3, 4, 1, 2, 3, 4, and 10. And so it's just very important to memorize this configuration. And don't freak out about it either, because you're only going to have to do up to this. They're not going to make you go past it. And I hope that helped with electrons.